So good morning, guys. Good morning to everyone. Nice to meeting you all. Thanks for the invitation. My name is David Correa. I am a technical solutions architect working for Cisco right now. In the past, my background came originally from the IT world, so everything that is enterprise in terms of security, data center, routing and switching, that was kind of my deal. Around 2018, 17, 18, I was contacted by an oil and gas company here in Texas. They needed a SCADA architect, which, to be honest with you, I didn't know at that time what SCADA was or what they were doing on the industrial side of the network. But let me tell you, it has been really interesting, and that's how, after working for this oil and gas company 2 years and a half, then I moved to Cisco, just on the same area, which we call IoT. But IoT really, guys, and you can see it from all of these conversations, IoT encompasses a lot of things. And also, it's kind of a buzzword in where people just think about maybe, a thermostat or a sensor or maybe a camera, but it's in reality much more than that. So one of the biggest initiatives that we have precisely on IoT networks, the SCADA networks, ICS, OTs, whatever you want to name it or call them, is that cybersecurity is a really, really big piece in this moment right now. And the thing with that is, if you think about the enterprise, all the enterprises right now, they have a solid background foundation in cybersecurity. If you think about any IBS, IPSs, firewall, security elements, they are very well protected. So what the attackers are looking right now in this new environment is that people is not really into these operational networks. The history has been telling us that operation networks are just to produce, right, and deliver a specific service 24/7 most of the time. So if you think about a manufacturing line, if you think about oil and gas drilling side, if you think about any other operational environment, the thing with that is, as long as I am producing and I am connecting specific devices, I'm happy with it. So you can see, and I'm sure you have seen a lot of environments in where you have maybe a switch, you have maybe a router. It doesn't really care about the brand. They are communicating because my industrial protocols now they speak IP. So in the past, I have Modbus maybe over serial connections, legacy connections, but we have those protocols now working in IP. You have Modbus TCP/IP, you have C protocol, you have Profinet, Ethernet IP. So everything now it's connected, and that's kind of the trend. So this is very important, very, very important that things are going to be more and more connected into the IP realm. So there's no escape to that. I don't see companies saying, yeah, I'm going back to serial because this is insecure. No. So that's why we are trying to help our customers to bring an architecture that can help them to have the enterprise, but as well the industrial piece of the network secure, communicated, protected. So how's the vision of CISO in regards to the cybersecurity? Cybersecurity encompasses what we call zero trust protection. I'm going to explain, or I'm going to talk about what was the old Correa model that a lot of companies are still using, trying to protect the assets. But nowadays we have the IEC 62443, which is kind of the new model that we are trying to educate customers and companies to adopt that, because it's a more protective way with several aspects that we have from the enterprise world, but with the capabilities of understanding the industrial protocols, which is very important for these networks. So here's just a couple of information that I just mentioned verbally about myself and my expertise with networking in general. So you can see that this presentation later. I don't want to, grab a lot of time on that. So what are the industrial trends? This is important. This is the interesting topics, right? Again, utilities companies, manufacturing companies, oil and gas, all these companies are trying to get more automation, more connectivity, and hence we need to protect them. Again, there's no way back. There's no turning back. They are going to be connected. And look at this. In the past, these networks are being so-called air gap networks. So they don't have connectivity at all to the outside world, except for the things that they have working there. And in fact, you might see in some customers nowadays that they still have, if you ask them how your industrial network looks, they will tell you, oh, you know what, we created a big /16 network that has 60,000 assets. Oh my God. Okay, so you connect all that, they are speaking between them from to the enterprise company. Yes, you can reach them from everywhere. Okay, that's a big issue, right? It's like these industrial assets, they need to be now more consolidated, very well discovered, interpreted. People need to know what they are doing, what they are talking. Why? Because if you're trying to provide more automation services, let's say you can see here the cloud, that's something that customers are adopting, especially on enterprise, but also on these networks. Why they will need the cloud? Well, just think about this. What for a customer in an industrial network, they will gather data. If they can gather data about the processes that they are running, what are the metrics about the network connection, what the devices are doing there, and they can move that data towards the cloud or any other system that in where they can report the results, that is information valuable not only for the operational team or the networking team or the security team, but also for your executives, your stakeholders, because now you are able and capable to provide what are the results of the things that we are doing on these ICS SCADA networks. That is very interesting, but there's no way that I can do that if I don't have a specific hardware or a method or a procedure that is secure in the way that I move that data. So this is very important, but this is the trend. How am I going to move that data towards other entities in my network or in the cloud to produce results and valuable information? So with that being said, we get into these type of barriers that these customers normally will see, where they will complain about, okay, I need to modify my environment. What should I do? Okay, so the thing is, yeah, there is certain complexity to that because operations are very critical. So it's not the same that I can tell to a customer, hey, Mr. Customer, I need to do a maintenance window at midnight because we are going to replace this. That is not going to happen. It's not the way that this works. I cannot tell manufacturing to stop producing just because I need to move or do a network change. Okay, so we need to understand that. Once we understand that and we align into how we can do this, it is important to mention that this network is going to be protected. That's the cybersecurity piece. So it's not only saying I am connecting your assets, it's how am I protecting your assets? An asset in an industrial network, again, can be everything. From a sensor, how it's communicating, from a PLC that is doing specific operations in the network, an HMI, which is collecting data from those devices, right, etc. So when I can tell the customer what those devices are doing in the network is the way that we are going to protect them. I cannot protect what I cannot see. And that's a very basic phrase that we use here in Cisco, saying, if you don't know what you have, which is also a pretty common thing, if you ask your customers, how many PLCs you have, how many HMIs you have, normally the customer is like, well, I think I have 50. Well, I think I have around 75 PLCs. Okay, you think you have, but you are not sure of the number of elements that you have in your network. Let me give you an example. In the past, I've seen this personally. When you have in these networks third-party vendors that they come and do changes, configuration changes, install new patch something in your industrial devices, they can use, for example, a quick gateway connection via cellular, so they can download a specific software, install it in your machine, and it's done. I have seen in the past vendors that they left cellular gateways connected to your networks, okay? even after they finish the procedure. So think about that. They connected something into your network. So they plug cable into your switch. Nobody knows about it. They do a authorized task into your network, that's fine, but then they forgot to remove the network. So what do we have there, guys? We have a potential pinhole into your network if somebody discovers the cellular IP and then they try to do penetration, right? And nobody knows, nobody is aware that the vendor left the cellular gateway connected. Why? Because nobody is monitoring this piece of the network. I guarantee you something, that won't happen in the enterprise. The moment you try to connect something into a switch, the port is normally shut down. The port has some alerts. So people in a SOC, which is the Security Operations Center, they will receive an alert. They can trigger an email. They can send a text, and we will ask, right? Hey, did you connect something into this? No, I did it. Okay, then it's blocked. Industrial networks, like I said, oh, I have my big size layer 2 network. I'm connecting whatever. Nobody cares because nobody is inspecting. Now, another thing that is very important is, and I don't like the way that this is described, the lack of skilled resources. I'm not going to call it in that way. It's not the lack of skilled resources. It's that the skills are very different, okay? So if you talk to a SCADA operator, if you talk to an OT assembler, manufacturer, etc., they will have specific skills on how the production line works. They know how to connect specific things into the network, but when you start asking them about, oh, do you know about port security? What is that? Do you know about a VLAN? What is that? Do you know about a router? What is that? They don't understand that piece. That doesn't mean it's a lack of skill. It's a different skill. So we need to educate. We need to educate people on the OT side to understand specific things that they need to know and they need to use to protect those assets. So those are the three things that we see on the industry. And let me tell you regards to cybersecurity. This is a problem, guys. Again, when you don't know what you have in your network, these things now, I'm sure you see this in the headlines, in the news. It's like what happens to Colonial Pipeline, okay? They got attacked. We have a big disruption of oil and gas in the East Coast 2 years ago, right? So what happens if my devices are doing a remote call into an executable file in one of my HMIs? How do I know about these things, right? And this is the key. Again, guys, why people focus on this pipeline thing? It's operational networks. Why they focus there? Well, because nobody was in. Nobody is monitoring those things, those assets. And let me tell you that sometimes we discover that attackers, they don't attack immediately sometimes. They can get into your network and they will be dormant for months, believe it or not. So you can think, oh, and this is very important because also there's another misconception. Hey, I have firewalls in my network. I don't need anything else. Well, I can tell you that is wrong. Why? Because my firewall normally will protect entry points, exit points in my network. If an attacker gets access through my network across that firewall, okay, that's the initial conversation. After that, if I don't catch that in an alert, when they get into the network, then I'm done. And the reason why is because they are going to be there, dormant for months, and then they don't need to speak to that firewall connection again. What they will start doing is what we call lateral movement, which is I'm on a server maybe, I hack that, I stay there dormant, then I enable my actions.
It'll come back.
Okay.
Times out and then comes out.
Jump up and down.
Oh, okay. So okay, nice. So that lateral movement is I'm here in the network. Now I have access. Then I'm going to start talking to computers that are on the same network on this lateral thing. So I don't need to go through that firewall again. Would I be alerted if this server starts some actions in my other devices on the same network? No. And who's monitoring that? Nobody. So that's a big problem. In fact, that's why you see these attacks. That's the explanation. Somebody hacked the entry point, they got access, now it's gone. The network is not well protected. So how we are trying to standardize or educate customers about what they need to do and how they need to do it is very interesting, guys. Again, industrial protocols are different. And this slide represents that. It's like, we need to make sure that we have a tool capable to understand the protocols that I am talking. If I don't understand that, then again, I'm lost. So this is an important remark as well, that when people tell me, hey, I have an IDS, I have a firewall in my enterprise network, can I monitor this? The answer is yes and no. Yes, if your devices are speaking the regular protocols that we normally know. Example, if your PLC is going to access a website, that's HTTP or HTTPS. That's pretty basic. But you know the thing is, the PLC is not speak that language. It's not going to speak HTTP. The PLC is going to speak industrial protocols. Like I said, maybe Profinet, maybe SIP, maybe Modbus, and it's communicating specifically to a controller. Nothing else. The HMI is accessing the PLC, yes, to do some actions on it. That's all. So when you think about regular traffic, well, your tool, your enterprise tool will be able to see that. But what about the other industrial protocols? The enterprise tool is not going to be able to see that. So if you understand these differences, if you acknowledge that, yeah, there are gaps in my network, then we can take some actions, right? So how we extend the zero trust security to these industrial networks? To me, the way that I envision this for my customers is in 4 steps. Like I said, number 1 is the customer needs the real asset inventory of all the things that they have in the network, period. If we cannot count that, I cannot protect you. When we gather all the elements, when we are sure what you have, we are monitoring that 24/7, then we have an answer. Based on what we discover, then we can help them to do 2 things. Number 1, like I said, if the customer doesn't have a proper network segmentation, we start to do it. If the customer has some network segmentation on the industrial areas, then it's more easy, it's more simple, because we can improve that network segmentation. Then, once we have these 2 basic aspects, then we can start talking about threat detection. Okay? Again, I cannot talk threat detection when I don't know what I'm looking for. Period. People that tells me, well, I have my antivirus, I have my IPS. That's okay. But it's really useless if you don't know what is in your network. Period. So that's a number 3. And finally, how do we investigate and how do we respond? So here in Cisco, the idea is to help customers to integrate with other tools that maybe they have already. So if the customer has a SOC, we integrate with the SOC. If the customer has a CM, we integrate with that CM. If the customer has other Cisco enterprise tools, Identity Service Engine is very powerful to do micro-segmentation. We can integrate with that tool. If they have firepower management services to manage Cisco firewalls, we can integrate with that tool too. So all that is important, because we are saying, Mr. Customer, you don't need to acquire everything that you maybe have in the enterprise for the industrial area. You can simply integrate, and it's really simple to do it. So here's an example of how companies, a lot of them, this is what they use, the Purdue model. What's the Purdue model? Is the representation, just like we do in enterprise. If you are familiar with networking in general, normally you will hear about, oh, we have a network access level, which is the point in where I connect all my computers and devices. Then a switch maybe will go into an aggregation point. The aggregation point is I have a better, more robust switch that can handle a lot of traffic. For example, I can connect 10 access switches into one aggregation. That's good. And then I can move that data into what is called a core switch, right? The core switch is the main transport. So whatever you have in place, maybe to connect another location or to connect to internet services or to the cloud. Then you have a couple of routers that you connect your aggregation switches, and there's the communication happening. Okay, so industrial networks, they don't have that, as you can see here. The model is different. The way that they move the industrial assets is what we call cells, areas. So in those areas, you will see I have devices down at the bottom as sensors, valves, PLCs, controllers, HMIs, SCADA devices, historians maybe at a higher level. That's what you will find in these industrial networks. So the Purdue model was how I connect those switches, how I move that data, and just look at this. This is very important. That's why it's in red. This is what we call an industrial DMZ, the militarized zone. That, look at that, it's a firewall. And that's a traditional concept, right? Like I said in the past, oh, we have a firewall. We are separated from the enterprise. That's what we do. We have everything industrial here, enterprise is their work. Well, that's not what we need right now. Because again, if a company is asking you that, hey, I need the sensors to report into a cloud system, because you will manage those sensors in the cloud system, what do we do? I can do nothing because I'm separated. I don't have communication to the exterior. Well, that's wrong. Again, we are talking about connectivity. So that's minimal security, and that's why we are transitioning or trying to help customers to transition to what we call the IEC 62443 system. And look at this. This is a new picture, which is completely different from the Purdue model. And what is this representation? You can see here that now we have those green lines, like pipes, we call them conduits. So the conduit now is a complete secure channel in where you are connecting different zones, and you can see I have different devices and also different firewalls in different locations. So now you are able, or you will be able, to have more control, more accuracy on which zones you divide, how you protect that zone, what is the conduit, what is transport. So all the information, remember, the more control you can have, then you will have more representation of data. And let me tell you what, with this type of connectivity, you can see we are not separating. We are not trying to segregate this anymore. This connectivity goes all the way up into the enterprise, and then they can reach internet or maybe cloud services, etc. But look at that. In this example, we have 3 conduits. All 3 protected, all 3 well-defined. So whatever is passing through your firewalls, at each one of the levels, you will be monitoring. So whatever happens, boom, you will be able to catch data. And not only that, in Cisco, for example, I'm sure you are familiar with a lot of our switches, even from the enterprise. I can mention, for example, Catalyst 2960s. Those are very famous in general. But we also have specific switches for industrial purposes. So when we talk IoT, not only from cybersecurity perspective, if you ask me, how do I connect my assets? I can give you several different switches that you can choose with different port densities, models, and features that you can put into this area. So we are monitoring not only from a firewall perspective. I can use my switch to connect my assets, and also from that switch, we have an application that can monitor your traffic. So on the same switch, on the same gateway, we are going to be able to decode the industrial protocols and see what your industrial devices are talking, which is a great thing. So in that, assembling this network architecture, what are the elements that we normally talk about with the customers? You can see here is a lot, but important key aspects. Number one, look at the foundation. The foundation is going to be, yes, I have network security, content security, right? Access security. That's the foundation. And then we can start go deeper into several elements. Why this is important, and I know it's a lot, I'm going to just put a keywords in the next couple of slides, But this is very important because probably a lot of companies right now, industries like manufacturing, for example, they are subject to audits, oil and gas as well. So nowadays, the regulators are asking for these companies to have, if they need insurance, for example, they will need to assert into these specific areas of the model, right? So if you are not protected at each and any one of those, you can get into trouble. You can fail in your audits, right? Why? Because we are getting into the deep pieces of this, like how you identify your devices, how you authenticate to your devices, right? And this is very important because, like I said, what we are trying to help customers is, Mr. Customer, now you have a proper hardware with a proper software that will help you to do all these tasks. So when we talk about having a powerful switch, a powerful gateway, now you can get these things done. So identification, authentication is who's going to make those changes into a switch, into a gateway in my industrial area? Do I have the proper controls to authenticate my operator so they can have access to the configuration of the switch or the gateway? Yes. Who logged into the switch? What changes did it make? We have that control. Tools that we can help you with is, again, our switches. This is an architecture that is unified, so you can use Cisco ICE, for example. My Cisco ICE software is capable to say, yes, my operator is Alice. Okay, what are the credentials? These are the credentials. Then everything is monitored through the Active Directory, for example. Then instructs ICE that Alice is a valid person. But not only that, Alice is a valid person, but she has certain privileges, so she can touch specific areas of the configuration of the switch or the gateway. That's very important. So these key concepts are the zero trust. Again, it's not only having a firewall, it's not only having a local user that can do changes. No, it's they can access, yes. What is the level of access, right? And also even time access, right? Maybe the operators are allowed to do changes after 6 p.m. Okay, then you can set that up. If they try to do something else in non-standard hours, then you will get alerted about these type of actions, which is very important. Cyber vision is one of our tools that can help you with that visibility, that level of visibility. And here's an example. Like I said, some of our hardware can work as a network sensor, passively or actively, depending on the customer, monitoring the network. So when we are able to do that, look at this, we can deliver the customer specific details about the devices that they have on the network and what those devices are talking. So this is a sneak peek, a small map about your PLC is doing this series of communications between those devices in your network. This is pretty important because, like I said, in the beginning, for customers that they don't have this level of visibility, there could be some surprises. And I've seen these with customers, and when we show them the map, for example, and we say, hey, look, that PLC is speaking with this Windows machine. And then they ask me sometimes the question is like, hey, that communication shouldn't be there. Okay, so my question back is, okay, if that shouldn't be there, my tool is telling you for sure that that communication happened. So if that is wrong, then you have something to do. So you see the value is like, from a network switch, they have this level of visibility. Now they can take actions. Like, that shouldn't happen. Okay, let's fix it. This is when we get interested and say, okay, let's segregate, let's segment, let's help you trying to avoid this type of communication patterns, right? Duo is a very powerful tool. Again, multi-factor authentication. That's very important nowadays, right? Even us, as a regular users for a lot of applications, we have multi-factor authentication. I know sometimes it's like, oh, I need to call the code. Oh, they will send me a text. Well, yeah, but think about it, right? It's the only way to make sure that, yes, my account is protected. It happens to me in the past. I received emails, legitimate emails that says, hey, somebody's trying to access your email. Was that you? I mean, tell me, because if that was you, you need to don't reply to this email. That we are going to allow that communication. But if that wasn't you, then we have a problem. And then you have an option, in fact, in an email or in a text to say, no, that wasn't me. So take an action, close that communication. So these are the things that Google does for you. And look, the capabilities of integrating with a different variety of applications, it's huge. Use control. Okay, use control. What is use control? Okay, use control is, yes, we have an access. We are allowed to make changes when that happens. Even if it's a legitimate change, we need to have information about when that happened, period. Why? Audit purposes, right? Hey, my technician, he was working on Wednesday this week on those PLCs. He made some changes. We detect the changes. We put them in a timestamp. Beautiful. That's my logging information. That's my changes notebook request. Everything has to be there. Again, for audit purposes, right? Who made those changes? It's valid. It's legit. Yes, we let them know. Okay. Now, when those access are not correct, then we can work in things like this. Like this. Like I said in the beginning, think about communication that is not going through the firewall, okay? And this is very important because from networking, from just networking, just think about a switch that has 10 devices connected. If those devices are talking between them, that is a communication that stays at that switch level. If you think about the firewall that is at the top, that firewall is not going to be able to see that communication, period. Why? Because the switch, and that's networking, like I said. So the switch has the capability to handle that traffic locally. The firewall has nothing to do with that communication. So that's why you will never see it. So then, if the switch, if the PLC is trying to access another PLC, why? That shouldn't happen. So how we can see that? Again, my switch acting as a sensor in the network, reporting to you, well, we detect this pattern. Is that good? Hey, hold on. No, that doesn't look right. Okay, let's suppress the communication. How can I do that? Okay, identity service engine, NAT control, microsegmentation. Can I instruct my switch via another software that, hey, isolate that port, isolate that device because we believe it has some malicious potential things doing in my network. Okay, I can create those type of matrices that from one to device one to this device. Yeah. Don't allow the communication.
He'll come back.
Okay.
Just give it a second.
Okay,
That's why we have Chris here.
good.
I saw it
Yeah,
coming.
it's a security process.
Okay, you see, security.
I had to get my two-factor to make sure we're okay.
That's fine. So this type of matrices that you see here is, again, from one zone to another, I can block traffic. From one port to another, I can block traffic or I can allow traffic. That's the level of segmentation we can accomplish with our hardware plus our software. Cisco TrustSec. This is the hybrid micro segmentation. So again, we can talk about areas, complete areas to isolate traffic, to prevent traffic, to allow traffic, or all the way down to say device per device. This device cannot talk to this server, but these others can. So that's very important. That's how flexible we can be, helping the customers to achieve this level of segmentation. And again, these are just examples of who is authenticating, who are you, what's the level of authorization you have. This is the way that we are going to move the traffic. Yes. Macro is like I have specific zones that encompasses maybe 10, 20 devices, X number of devices. And then micro segmentation is saying this port, which is a specific device, to this other device. This is very important. System integrity. System integrity, guys. Integrity just means that whatever I am communicating is going to reach the other end without any tampering. Okay? And why that is important? Because also in industrial networks, guys, it's funny. Industrial networks, like I said, they came from this legacy connectivity. So when they transform into the IP world, they made it pretty basic. What I mean by that is they never thought about security at all. The idea was to say, okay, just like in TCP/IP, I will have a header, I will have information, I will have a tail, right? That I can monitor the frames over the wire, period. Nothing else. So the moment you realize that it's not like IP version 6, for example, we have a big IP address, big headers that they can do security for you embedded on the same IP. It's not the same. They just worry about this will work over the wire. Yes, period. So how we are going to protect that? Can I do encryption on those protocols? The answer is no. It's very difficult. I mean, even if you try to put a regular switch on industrial networks, sometimes the traffic could fail. Why? Because the headers are different. They weren't focused on cybersecurity. So again, it's our mission to say, put a proper switch that can handle that traffic. Let's put a proper firewall that can understand the industrial traffic. Let's put a proper sensor that can monitor that traffic. So the moment we detect any type of changes in those headers, payloads, we're going to be able to see it, and we're going to make sure that the system has integrity. That's what we do, with this level.
So I have a question.
Go
So
ahead.
some of the newer IoT, for instance, LoRa, are going over the top and not using IP. They're using their own security protocols.
Okay.
So they're leapfrogging over a lot of this IP stack and then going tunnel directly IP to a centralized server. So they're already putting their own kind of leapfrog over the top security with security keys. So then the focus becomes cloud security versus device security because of the new hub and spoke way that it's working, right?
Yeah.
So it's not necessarily what you were suggesting at the old wireline. There's actually new security protocols over the top.
Absolutely. But let me tell you also something about that. And this is my personal opinion, of course. That type of do things is sometimes not the best, I will say.
It's secure.
I know, but there's a reason why. Proprietary protocols could be good, yes, but then we think about customers that they will need or they have, especially in industrial areas, they will have a mix of brands doing this.
LoRa is an open protocol, right?
Yeah.
Yeah.
That's true. But when I start doing changes like that,
Yeah.
like, hey, I'm going to encrypt with my own protocol from here to there, we can get into interoperability problems. And that's why in the past, we used to have DEC, Xerox, Intel, right?
Yeah.
Doing Ethernet in their own way.
But that's manufacturer-specific protocol.
Exactly.
Yeah.
So to me, the way is, in Cisco at least, we say, okay, we know that standardized across the board, we have protocols like Profinet, like SIP, like EtherIP, we're going to use them.
Yeah, they're highly insecure for the most part, too.
They are highly secure, but that's why we are getting
Yeah.
to this level of access, saying, let's monitor those, let's protect them, but still, we are using techniques that they are available for me in case that, hey, I have a Cisco firewall. If I want to do a VPN with another brand, can I do it? The answer is yes. In case that I want to say, hey, no, I'm going to close this to Cisco protocols, and I'm going to move this data all the way up to the cloud in my own way, the moment that the customer says, hey, I want to change maybe a switch in the middle or maybe this device in the middle because it's not useful for me anymore, then they cannot do it, right? And believe me, even myself, that I work in Cisco and I like Cisco, for example, EIGRP in routing, it's a great protocol. If you ask me, have you deployed a lot of EIGRP? The answer is no.
No.
Why? If it's great, yeah, I know it's great. But even I want to have EIGRP, the customer sometimes will say, no, you know what? I prefer OSPF as a standard because someday maybe I want to replace your router. I want to use another brand.
BGP and
Feel
everything.
free to do it,
Yeah.
you know. So I believe more in like, yes, let's understand this better. We are making sure that, yeah, the protocol is insecure. Like I said, yeah, no questions about it. But now, how we can help keep it and protect it. So this is the way. And for example, in deeper levels, secure endpoint, right? So my HMI, it is a Linux system, it is a Windows system. Okay. Can I improve the security on that? Of course. Let's put an endpoint security protection software there and signature. Anything that we detect malicious is going to be reported. At some point, this type of integrations is like actions, right? It's like a playbook. Hey, my endpoint is receiving something anomalous from that Linux server or that Windows server. Okay, isolate. So we receive the alert from the endpoint software. Then I have eyes. We know where the server or the HMI is connected. Block that port until we patch it, or until we receive new information that maybe was a false positive or something like that. So that's kind of the key that we do, right? And again, in terms of hardware, we have beautiful boxes, powerful firewalls that can do that inspection for you, right? One thing is IDS, which is the detection system. So we are capable to detect, yes, but also the other part to that is the IPS system, right? Which is the prevention mechanism. So one thing is, yes, I detect, I alert, I report, good. Can you prevent that to happen? The answer is yes. In some of these boxes, you will be able to cut that traffic down if we detect something anomalous. Look at this for the industrial areas, the industrial pieces in our portfolio. All those devices that you see there are specific for the industry. What I mean by that is those devices are fanless, ruggedized devices that they can hold and support higher temperatures in those manufacturing lines. Some of them are IP67, so they will support even water. So obviously you can see also the connectors on the white one at the top right. Those are different. That is an Ethernet, but it's called the M12. So that type of connector, you just put it there, and if you put some water into the switch, it's not going to break it down. So you are guaranteed that these devices can hold those hazardous environments. And myself, specifically, when I was working in the oil and gas, can you imagine the temperature in West Texas in the summer? It's about 100, right? So those switches have been working there at that company right now for almost 5 years now. Failures, none. So pretty reliable systems that you can tell your customer, hey, this is a good switch, instead of going to Best Buy and get unmanaged 8-port switch that maybe can work, yes, but you cannot do anything with it. You cannot get any data. You cannot collect anything from it. So how you can report what is happening in the network? Like I said, also our software on this industrial cyber vision will help you with things that you can see on the slide. Is like, hey, we detect new activities, we detect new variables. This device is trying to write or read from this PLC. Those are the alerts that you will receive. And again, right, the customer is like, okay, this looks good to me. Then you can acknowledge that the communication is okay. Hey, this doesn't look good to me. Then you can report this type of communication, and then we can take action with other tools that we integrate with this hardware.
Okay, so I can ask a question.
Yes, please.
And this may not be relevant to you, but there may be somebody else that can answer this. And Chris strikes me as the guy that might.
Maybe.
So a very specific case, IoT related. So I mess around a lot with MCUs, the semi-famous ESP32 from Expressive Systems.
Yep.
The Chinese company. Is there a certification I know you cannot prove a negative, but who certifies that there is nothing running on that chip that the general public doesn't know about, but some geek in Beijing knows about?
That's actually a great question.
I actually know the answer on that one, but on that chip.
Okay,
But
but in general, right?
if you were to not trust the documentation, you would,
Yeah, I'm saying it's way past trusting the documentation. I'm saying if you don't dissect the circuits on that chip yourself, how do you know what's really there?
pen testing, penetration testing. So it does have an IP stack on it. And does have, in particular on that chip, it is a Wi-Fi based chip with a 802.15, whatever, I forget all the protocols that it has on it, but it is Wi-Fi based. It is IP based. If it were to join a network, this would catch it.
Only
now.
So is that really true? See, I would believe you, but
so really, on that can be, because that chip has the following protocols on it. It's got a Bluetooth, which is wildly insecure, because anybody can hack Bluetooth.
It's going to be insecure, really.
Yeah, it can be hacked on Bluetooth, so you would have to turn that off. Hang on, give me just a second. It has a Wi-Fi stack on it with an IP stack this type of solution would help.
So in this day and age,
and it's also got a proprietary stack on it that you probably don't know about, where it's doing the ESP32 stack, which I don't know if you played with, right?
And maybe you don't even, maybe the point would be you don't even want to inappropriately get data out of it or put data into it. Maybe you just want to brick it. And is there a way, in other words, if you don't know, does somebody disassemble those circuits, extract those circuits, and certifies, there's nothing
you're talking at the hardware level.
Yeah. I think, Chris, you're right. And let me add to that. There are a couple of things that, like you said, we wouldn't know, we won't know until somebody figures that out. One of the things that Chris mentioned is penetration testing, pen testing. So pen testing means we need to go deeper. We need to make sure what is in there. So there's no way that know what is in there unless you force it, you discover, you investigate it around.
Like there's a proprietary stack in that chip that you may not know about.
Yes.
I don't know if you've used their little ESP proprietary communication stack.
Oh, then I intend to use that.
Yeah, and that one's proprietary, and you really do have to do some testing on that one.
Exactly, to discover that.
Yeah.
And keep in mind, and this is very important, there's another thing that we have, which is a big gap in the industry, in the whole security industry, that nobody knows really how to solve it, which is called day zero attack. Day zero attack is precisely that. It's something that we don't know. It's there, yes, in a lot of things that we thought they were secure. Even all hardware from all vendors, they can say, yeah, my chip is secure, you cannot hack it, my core, my kernel, and my operating system is untouchable. Yes.
There's backdoors in
documentation says that, but somebody, like we said, around the world, they are sitting there in a lab, dissecting that, saying, well, this is not as secure as we thought. So the answer is, when they discover that, normally, well, people can tell the company, like, I discovered this, you have a flaw, you need to fix it. Probably they will give it something, or, they can be hired company in a good way. In the bad way, it's like they are not going to let us know.
Yeah,
they
so in the bad way, it's a Chinese company. And I believe that the Chinese government is completely and totally unlimited in the level of evilness that they would.
You have to go. You have to make sure you're not compiling in that other communication stack, that proprietary one. Because if you use the ExpressF tools and you accidentally compile in that library, it's not secure.
Exactly.
And just because I know you're working on those, so,
Yeah.
and I am too, so.
Now,
Yeah.
and another part to this story is that there's an initiative, and probably you've heard about it, it's like Build America, Buy America, right?
Yep.
So the intention is that manufacturers of these chips, microchips, etc., they are manufacturing everything here in the States, right? And hence you will need less of those chips that are manufactured overseas. Because otherwise, yeah, like we said, there's no really a way to say what they are doing. Are they tampering these chips? Are they putting this in that? Maybe, maybe not. We don't really know. And we cannot discover that unless we do a penetration testing, a dissection of those components, and making sure that, yeah, those are safe.
Yeah,
And-
but you're like 3 to 5 years out
Yes.
in terms of manufacturing in the US. And so his concerns are pretty valid because by
Yeah.
that time, technology is going to change anyway.
Yeah,
Yeah.
use an RP 2040 instead. It's.
No, absolutely. And it's sad because, yeah, the right, if you want a straight answer, it's like, no, we are not 100% secure. And those things are going to still happen. So at least having certain level of protection that you are able to see those things, it's a certain way, yes. But yeah, on the other hand is, yeah, we are going to be always vulnerable to those type of things. So yeah, keep in mind that it's interesting, but yeah, it's sad. I think that.
A couple of things that we're talking about here that I think we're kind of going around the subject, but you definitely made mention of these things. First of all, on the hardware side, certainly if it's critical infrastructure, that's where you can really lean on the OEMs to say, okay, what is your hardware supply chain? Okay.
Well, see, so my point
it
is,
traceable?
if it's a Chinese company, there is no basis for
Absolutely.
believing a word
And
they
if
say.
that's- My point is, if that's a first order concern for you, then you need to go find the OEM that is putting traceability into that equation. And so that you know that if there's a Chinese chip or multiple chips on here, I know exactly what they are and I know what their functions are. Okay, so that's point one. Point two is,
Well, so my question exactly to your statement is, and my question really was, is there a certification body? And I don't think there
I
is,
don't.
that
not that I'm
says
aware of.
we have disassembled this chip and there are no circuits on it that are not disclosed in the documentation.
But
I've only
there
seen
are
corporations that
OEMs.
require pin test and testing, and they want to see that.
They want,
And they'll contractually, not due to spec or boards or anything, they'll say, contractually, I want a pen test report on this every 1 to 3 years or something. They're gonna say, and I have seen that.
okay.
But that's by contract.
We've got two separate issues that we're talking about, and yes, pen testing is important, but we're talking about A, the hardware, and then B, we're talking about the software. And when I say software, I mean, literally, application, OS, firmware, et cetera. Okay, so those are two separate topics.
Correct.
Okay, the first one, kind of just want to tie a bow around it, that if that hardware is something that is, mission critical, and there are OEMs that cater to that business model, and you're going to pay more for that, and then perhaps you even need to custom contract out, creating those boards to the exact specification, and that so you have traceability from the chip all the way to fab.
Yeah.
And the finished product. So that's point one. Point two is, our view of security is certainly, it's all around best practices. Okay. So I know you threw out, Laura, earlier, well, if you don't have your keys properly configured,
They don't
you
work.
have your ports properly configured.
They don't work.
If you don't have your firmware, up to date, that's right. You've opened yourself, even though if you think this is the most, secure set of protocols, platform, etc. if all of that is not properly configured, then you're just as vulnerable as if you picked, some other less secure stuff, if you will. So, kind of on that one is, all of the best technologies are not going to save you. The best practices applied to those technologies are, and that's we say 85% plus of security is implementing best practices on the device. Okay, so I think those two things, if you look at those things objectively, and then to your point, you wrap those in testing, and then you go through and you're very systematic about it, that's going to solve 95% plus of your problems. And security to me is akin to fire ants in Texas. Okay, it's kind of like you go buy your fire ant killer, and then you spread it on your lawn, and what happens? They don't really die off completely. They just move to your neighbor's lawn. So the point being is, if you put all of that in place,
Yes.
okay, if you put all that in place, the bad actors, they'd rather not go after you. It's too much of an effort. They'll go to your neighbor's house. So I think that ties back into
Exactly. And that's what it is. We are going to be vulnerable all the time. But depending what you have in place to discover these type of things or your procedures. Look, another important data, now that you mentioned that, is the social engineering, for example, is still a big issue in the industry.
Oh, it's the
So
number
that's
one
best
way to hack.
practices right there, right?
It's number one hack.
Exactly. So even if you have the best technology around the world, the best possible chip manufactured specifically for you, if one day I call into your office and I don't know, you or any other of your colleagues give me access because I convinced them that I was X guy that will help them with this or that, they give me access to the system, you're done. It's like you can put any locks in your house, but when the robber knocks your door and says, hey, I'm gonna rob you, please open the door, you open it, you're done. So it's the same example, and you're right. I mean, in that part, they are not gonna go away. And again, you can see articles about computers, even PCs, any brand. They develop like, oh, you are protected on this chip. It's unhackable. It's very secure. We put physical security on the chip. We have a hardened code. And then, I don't know how, 2 months later, you see on the news, oh, we discovered a big flaw on Apple chips, Apple M1, Apple M2. So again, there's no like a regulator or, like you said, a body that makes sure on compliance about manufacturing. You need to have some certainty of traceability, which I don't think we could, or
That's why we banned
but
certain chips.
yeah. But at the end, somebody will play with those things. Somebody will try to discover, try to ruin it, try to say, yeah, this is something that we can penetrate, and that's it. If we don't have best practices, they are going to try to hack us every now and then. If we are secure with best practices, like you said, they are going to say, this is too much effort. I'm going to go to the next door, and period.
So UT Dallas has a research team focusing on just this topic. So I recommend you go to Yorgos Makris or Aria Nasratinia at UT Dallas. They got $1 million from the National Science Foundation to look at chip security.
It's a problem.
So it so happens, I just work in the middle of a dozen guys who all they do is circuit extraction. And that's why, I mean, I'm not, personally, but to me, if you wanted a world-changing thing, well, then you would sell tens of millions of chips that there are circuits on it only you know about.
That's why the Chinese camera chips are banned in the US.
Yeah.
They found vulnerabilities in them that were
Now,
exploitable.
what camera? I don't know what you mean.
There's no Chinese camera chips allowed in any government installation because of vulnerabilities
Okay,
that
in the
were found.
government. Oh, yeah,
Mhm.
yeah,
But they were only allowed to do that for government regulation.
yeah, yeah,
Because they can't control private industry.
right.
But they're banned in all government sites by law now.
So it's almost like a business opportunity for NIST on steroids. Like,
There
you know,
are,
like somebody like UTD. Literally, this chip, every circuit on it is described in the documentation, and we've taken it apart, and we know there's no circuits on this that aren't disclosed.
You're-
And, you
you're
know,
seeing
there's-
some
there's-
movement in the hardware world,
If you're
right?
Yes.
making drones or
Okay, just one more slide and,
you want your chips.
we wrap up.
Let's have David wrap up here now.
Yeah, no, absolutely. So at the very end, guys, I will say that the important things are how we consolidate all this information and how we integrate with other tools. I mean, in terms of research, for example, in Cisco, we work with Talos. Talos Group is the largest, I think, around the world, working every day on getting new signatures, new discoveries about attackers, what are they doing with hardware, software, etc. So if you think about that, it's also, this thing is not one thing that we solve all the problems with one tool. It's a series of tools along with best practices, understanding what we have, how we want to protect, and make sure that, yeah, on top of that, we are covered by a certified industry. We are covered by a good research in security. So every time that things changes around the world, you are going to be safe because we are on top of that, updating signatures, databases, etc. So your services and your devices will be protected. But again, it's a combination of factors that it's interesting, and this conversation goes interesting with that about what is physical security, also what is network, software security. But at least you know that we have tools that can help you with your industries and customers in these areas.